All right, so yesterday we were working on classwork 4.5, didn't quite completely get through it, but here's the bottom line. You're expected to know that a polynomial of degree n has n roots. However, those roots could be numbers that are out of the dimensions that we exist in, so to speak. And so anytime the number I comes with a 0, then that is something you are not going to be able to visually see on the graph, because you have to go into a 4-dimensional space to see it. And we're not doing that. That's your joy. Okay. So, come on, scroll. Okay, don't scroll. Now scroll. There we go. And another thing is, if a factor repeats itself, each repetition counts once each time it shows up. So basically, if you have a multiplicity 3, then that counts as 3 roots of your polynomial. So you always have n roots of a degree n polynomial. Now, if you have a root that has an I in it or a square root in it, you need to bring in the conjugate pair with it. And when you multiply, you're going to want to multiply the conjugate pair factors first. So I was starting to talk about this when we ran out of time. For the conjugate of an imaginary number or a root, it's about changing the sign on the term that has the I or the term that has the root. So if you are looking at this right here, I'm going to start down here. When I have -2 minus root 3, its conjugate is -2 plus root 3. And all it is everything is identical except for the positive and negative in front of the I or the root. If there isn't an extra number, like if I didn't have this -2, 1, and -3, then it's just you want to have it and its opposite signed counterpart included as your zeros. Otherwise, it's going to be ugly when you try to multiply, and you'll have things that you didn't want to have. So I don't know if I clarified well enough that I squared, I'm going to scroll back up. I is the square root of -1. I squared has the square root and the squared cancel, and it leaves you with what was under that root, which is a -1. You have to be aware of that, because otherwise, if you square before square rooting, you'll get the wrong answer. Now, what I didn't get a chance to do was talk you through these problems. So I'm going to go over to this point and talk you through, wait, that's the homework. Some of those classwork problems right there. If you're not given a leading coefficient, let it be 1. It makes life easier. What you're going to do is to write the polynomial, you're going to have a factor for every root. There are 3 roots here, and each time you're going to write x minus the root, x minus the next root and x minus the last root. When 0 is one of the roots, we tend to write this factor as just plain x in front. And when we are subtracting a negative root, we tend to just quickly go to plus. So know that I'm expecting you to write this line perhaps right away. You do not have to write this line the way that it is. You can go straight to this if you please. Now, the thing is, the next bit you have to do is multiply all this together because you are supposed to write this in standard form. And I want to repeat something I said a moment ago. If they don't give you information for a leading coefficient, let the leading coefficient be 1. However, the homework problems gave you information to get a leading coefficient. And when you're deciding to start multiplying, it's up to you which pair of numbers you want to first multiply. Maybe you look at this and you want to multiply these two together, and then after that, distribute the x through. So when I multiply those two, I'm trying to draw something a little too quickly, x minus 3 and x plus 4, you can do the box multiplication, and that's going to give you x squared, negative 3x, positive 4x, and negative 12. So this part needs to be brought back with what we already had. We already had x times, and then we just found that when you multiply these two, we get x squared. And you can go ahead and just add the like terms together. Negative 3x plus 4x makes positive x, and then minus 12. But still, you're not in standard form yet. You can be there once you distribute the x through to get x cubed plus x squared minus 12x. And now that is in standard form. So you're basically just, I'm sorry to say it, but you're having to do a lot of tedious multiplication. And I'm trying to give you reasonable stuff because there are some things that are horrific. Horrific. Just way too much multiplication. So when you look at this problem number 2, you need to know that you need the conjugate, negative 2i, to be a root as well. Now again, no information is given about the leading coefficient. So all you're going to do is make the leading coefficient be 1, and then write the factors of x minus the root that is 5 times x minus the root that is 2i times x minus the root that is negative 2i. So I'll change that to plus 2i. Okay, that's fine. And also, when you do have a pair of conjugate roots, you want to multiply that pair together before you combine them with anything else. It will save you a lot of pain. So I'm going to focus on multiplying these two together. X minus 2i and x plus 2i. And the reason conjugates are amazing, keep watching. X times x, negative 2i times x, positive 2i times x. Haha. Add those together. And then multiplying the last box, we have negative 4i squared. So that means that this portion is x squared plus 0x. Add those together, you get nothing, minus 4 times I squared. But every time I squared shows up, you need to simplify it by replacing it with a negative 1. So I have x squared minus 4 times negative 1. and that gives me x squared plus 4. Then at that point, you're ready to bring it back together with the rest of the function. So f of x is equal to, we had x minus 5 already, and now I'm replacing with x squared plus 4. Then you'll go through multiplication again with x minus 5 times x squared plus 4. And multiplying, we get x cubed. Multiplying here, we get 4x. Multiplying, we get negative 5x squared. And multiplying, we get negative 20. So finally, we get, add like terms only, x cubed minus 5x squared plus 4x minus 20. And notice that this time we didn't get the lineup of like terms. And you might see why if you take a good look right here. That x squared plus 4 has a 0x technically, so you would need to make another column if you wanted it to line up. But if it doesn't matter to you whether it lines up nice or not, you can just look in the box and add like terms and be done with it. So there you go. And then this just continues. And I'm thinking about how much time should I spend on this. So I'm going to move over to number 4. With number 4, you want to recognize that these two are telling you about x-intercepts or zeros, whereas this is telling you about a y-intercept. Through that y-intercept, you can find the leading coefficient. So with a problem where you are not told the leading coefficient, but you are instead given a y-intercept or some other point, then when you set up your function, you're going to just start off with some, I don't know what you are, C, and then, yeah, I agree on that. That's why I want to be I'm trying to rush through this, and then I'm going to hit 4, 6. So the zeros are 2, so x minus 2, negative 5i, but the conjugate has to be there as well, so I have to have this on top of it. You'll multiply that all out. Once you get it multiplied out, you will then plug in 750 for the f of x and 0 for the x's, and that will allow you to find your C value. Now, 4, 6, I need to move on to it. And I hope that helps a little bit with what you were doing there. But I've got to get onto this because this time we are dealing with polynomial division. And you need to pay attention and you need to listen very, very carefully. So, is everyone with me on this? This is going to be a lot easier if you listen very carefully. Now, whatever you are dividing by, start by writing that. Oh my goodness. Thank you. Other people are not thanking you, but that's okay. Start with what you are dividing by. So I am dividing by x plus 3. Now, when you multiply polynomials, the result of the multiplication is what ends up being inside the boxes. What you are trying to do is find out, what do I need to multiply x plus 3 by to get that polynomial that I put in green? And for you colorblind, the 2x cubed plus x squared minus 8x plus 5. I need that third degree polynomial to show up inside the box. So I'm going to show you how to do it. Listen very carefully. Every single time you start this out, you're going to take, now the person that is being, or the polynomial that is being divided, take its highest degree term, write its highest degree term in the upper left inside box. That will always be your first move, along with writing down the x plus 3 that you're dividing by. So now you need to figure out what should go here. And if you look at it, hopefully you see that you need to figure out, what do I multiply x by, right, to get 2x cubed? And that would be 2x squared. Yeah. Then, now that you know what this is, you can now find what goes in this box, because you're going to multiply 2x squared by 3. And that's going to give you 6x squared. Okay, I'm going to see if I can erase my highlights. Darn it. Okay, I'm going to have to rewrite it. There we go. Okay, now, this is a moment you've got to pay attention. You have got to pay attention right now. Does everyone understand? This is the part that you have to remember. What do I do now? I had shown you before with multiplication how the boxes line up diagonally with the like terms. The two boxes that I just highlighted have to add up to make positive x squared. So you need to figure out, what do I need to, quote, add to 6x squared to get a result of x squared? So I'm going to write that down. 6x squared plus what is x squared? And your answer? Oh my goodness, that's funny. So that means I'm going to have negative 5x squared in that box, and the process begins again. And I erase that negative. Okay, so that's one round. Are you ready for round 2? Here comes round 2. You need to figure out what goes here, and apparently you already have. I need this to be negative 5x if it's going to multiply to x and give me negative 5x squared. Then the next thing is, I can determine this box by multiplying the 3 and the negative 5x. And then the next step is the one that people have a little bit of difficulty remembering. And that is, you need to make a diagonal whose sum will give you the next term. And what would that next term be? Right. Because negative 15 plus 7 is going to give me that negative 8. And now that process, so we just processed twice. Whoop, whoop, whoop. Here we go, third round. What do I need to multiply this x by to get 7x? 7. Since I know that's 7, what goes in this box? 21. And then you want to remember that the next thing you are looking at is this diagonal needs to add up to positive 5. So what needs to go here? Now, are you ready for the moment of, oh dear, or I don't know. With a polynomial, the least degree term you have is a constant. So when you're dividing and you finally get to the column that has your constant, that's it. Anything that does not fit into the boxes underneath. So I got that these three together are a result of division. Anything that does not show up in the boxes underneath that polynomial exists in the remainder. And if you remembered with division, there's an unfortunate remainder that happens most of the time. So, yeah. Yeah, this is something you want to be talked through. So the quotient is always whatever came out of your division nicely. So that's the 2x squared minus 5x plus 7. The remainder is the negative 16. And then there are two formats that you can write the answer in. You can either take the polynomial p of x, which is referring to the polynomial you began with right there. You can rewrite that polynomial. So when I rewrite that polynomial, I'm saying 2x cubed plus x squared minus 8x minus 8x. That looks horrible. Bugs me. And then what was the constant? Plus 5. This polynomial is equal to, this is the divisor, which is the x plus 3, multiplied by the quotient, the 2x squared minus 5x plus 7, plus the remainder that just decided it was going to be annoying, and I'm going to write minus instead of plus a negative. So what this is trying to show you is that you can rewrite a polynomial based on the result of your division. The next piece is looking at if you want to write the result of your division. So this is saying that you are taking, and technically this is the dividend, but I do not want to get caught up into too many vocabulary words. The polynomial that got divided, 2x cubed plus x squared minus 8x plus 5. It was being divided by x plus 3. So the result of that division is the quotient plus the remainder that was not able to be divided by the x plus 3. So under some conditions, you're going to want to rewrite your polynomial. In other conditions, you're going to want to look at the result of the division. And so this just shows you how each of those two is written. Now, it's time for another one. Let's go. Do you have to do both, or can you only do one? Oh, you mean the answers. Any question is going to specify how it wants the answer presented. So you won't have to do both normally. And if I'm not clear in my directions, you can pick one and I have to accept it. Because then it's my fault for not giving good directions. All right, so here we go. Let's see if you've got this. I have a division. So I'm going to take what I'm dividing by. I'm dividing by x minus 4. And the polynomial that I am dividing needs to appear on the inside. And always there is a first thing. And that first thing is the leading term goes in the upper left box automatically. Then you can figure out what goes here by asking yourself, what do I need to multiply x by to get x cubed? The forms will be given to you with the problem to say, write it in this form. You just need to make sure that you're clear what each letter represents. All right, so x times what is x cubed? X times what is x cubed? Am I just not seeing chat? Did someone type it into chat or? Oh, my chat wasn't scrolling for me. And then I write it up here. And now I'm ready to do a multiplication. Negative 4 times x squared gives me. And then for the big step, this plus its diagonal have to add up to make the second degree term. So what do I add to 4x squared, or what do I add to negative 4x squared to get negative 2x? And so that's you've gone through the process one time. Second round. For the second round, I am now trying to figure out what do I multiply x by to give me 2x squared, and that is 2x. Good. And since I figured out what that was, I am ready to multiply to get this square. So negative 4 times 2x is negative 8x. And then for the big step, this box plus its diagonal box need to add to make the next term down, which is the x term, negative 23x. What do I add to negative 8x to get negative 23x? Good, negative 15x. And you just finished another round. Time to go again. X times what gives me negative 15x? Yep. And now I can find this box, negative 4 times negative 15. And now I want to look at this plus its diagonal need to add together to make positive 60. And then you go, what? What? Right? Are you doing that? No, you're not. Okay. 0 is the only thing that I can add to 60 to get 60. And what makes that such a wonderful moment? There is no remainder. So every time you reach the division place of your constant term has been written for the quotient, everything after that is remainder. Remainder. So the answer to quotient is x. What the heck just... Okay. The quotient is x squared plus 2x minus 15. The remainder is 0. So now when I rewrite the dividend, the polynomial that was being divided was x cubed minus 2x squared minus 23 plus 60 minus 23 plus 60. So that polynomial is equal to the divisor, x minus 4, multiplied by the quotient, the result that I got from dividing. And if there is no remainder, there's no need to write plus 0. So take a good look at that and realize what you just did. You just factored a third-degree polynomial. You have not completely factored it, but you have made a first step in factoring it. And that's why you have not been able to factor with degree 3 and higher until now. The result, the other way of writing it as the result of the division would be the polynomial being divided, 23x plus 60, divided by the divisor is equal to the quotient. But since I don't have a remainder, I don't need to write plus 0 over x minus 4. I can just leave it. Now, I'm going to move a little bit forward in case we run out of time. Oh, wait. Did I remember to make you a quiz? I don't think I did. Congratulations, because of the other class testing and me being so focused on that, you can't have a quiz today because I failed to remember to make one. I was too, well, anyway, here we go. I'm going to just do 4A for right now. This is asking you to use the results from problems 2 and 3. In problem 2, we were able to factor this polynomial So I'm going to take this right here and I'm going to rewrite it at 4a. So I need to remember x minus 4 times x squared 2 negative 15. 2 negative 15. There we go. And you are going to take this one step further and factor the quadratic. And notice that this one that I just highlighted in blue is a linear factor. And when you have a linear factor, that's as far as you're going to go. So I have x minus 4. And can you factor that quadratic into two factors? And those two factors are yay! X plus 5 times x minus 3. So this now shows you how you can factor a degree 3 polynomial provided that it is factorable into linear factors. Which, once you have those linear factors, you're then able to graph. So I'm going to leave the additional practice problems and move over to those practice problems are really important. Is your work on here said, uh-oh, did I screw something up on the answer key? It does happen. So that was this right here. We feel good about that. Did I have the, oh, Well, isn't that embarrassing? Wait a minute. Is that the same? Wait, that's different. Actually, I think it does. Tell me if I'm wrong. Are you looking at something else where that 16 is showing up? Is there anything I need to correct? Okay. Yeah. There's a lot of problems in here. And had we had an hour and a half, we could go through more examples. And that practice is very, very beneficial. I've got to move over here to make sure that I get through all the content. So you are now going to be asked to graph a third degree polynomial after being told what one of its linear factors is. So what that means is you are going to begin with division. I'm dividing by x minus 1. And the division begins with taking what is being divided, put its largest degree term in the upper left corner of the interior box. Then ask yourself, what do I multiply x by to get x cubed? And then you can multiply x squared with negative 1 to find out what's in this box. And next is the big step where you have to look at what's here and and find its diagonal box, because those two have to add together to make the degree 2 term of positive 4x. Oh, wait. Were you one of the people who... This class has a lot of colorblind people, doesn't it? That's unfortunate. It makes this harder because I'm trying to help you with color coding. Oh, just 2 of you. 2 is a lot, though. Maybe it's not. I don't know. So, negative x squared plus what will give me positive 4x squared? Negative x squared plus something gives me 4x squared. 5x squared, good. Then, x times what is 5x squared? And then 5x times negative 1. And that brings us back to do, re, mi. Huh. I don't know if you even... Anyway. Negative 5x plus this next box has to add together to give me my next term, positive x. And what would that be? Good. 6x. Ah. Okay, I'm leaving you highlighted. Then next, x times what is 6x? And do you notice that as soon as you put down a constant term, then this is it. 6 times negative 1 is negative 6. And if that is not my last term, that means that somebody lied and x minus 1 is not a factor, because I would have a remainder then. So if you are told that something is a factor, expect to get a 0 remainder. So that was step 1. Step 2, the polynomial f of x, we now know is equal to x minus 1 times the quotient x squared plus 5x plus 6. And I can factor this quadratic. What is the quadratic that I got from my quotient? What does it factor to? It factors to x plus 3 and x plus 2. I multiply, I get positive 6. I add, I get positive 5. Yes. So what does this give me that allows me to graph? This gives me my x-intercepts. What are my x-intercepts? I get my x-intercepts by setting each of those individual factors equal to 0. And those are the roots. You have 3 roots or zeros. Each has multiplicity 1. So because they're all multiplicity 1, you're going to slice through the x-axis at each spot. You can also find a y-intercept. On the homework, I made sure to have promptings for what you need to find. So y-intercept, plug 0 into all of the x's, and you will get negative 1 times 3 times 2 So I believe that would be -6 if I can multiply this afternoon. I have 4 points that I can now plot. I have the point y-intercept -6. I have x-intercept 1, -3, and -2. End behavior will help me get a graph going. And I'm going to find end behavior most easily if I come back to the standard form. So looking at this standard form, what is my leading coefficient, positive or negative? My leading coefficient is +1. That tells me that the right end heads up. Is this polynomial even degree or odd degree? Odd degree. So that means that the left end will do the opposite. I also remember that I have all multiplicities 1, so I will slice through the x-axis as I go through, and I'm not going to draw a perfect graph. That's okay. So I'm going to go near, near, near. And this is not perfect. I do not expect you to know how high this goes. I just expect you to turn around because you've got to turn around to get back to the x-axis. We do know this 1y intercept, but we don't know if it goes further down than that. That's okay. Just you have to make sure to come back to cross the x-axis again. Let's look at what it actually looks like. So here's what it actually looks like. And I want to say again, what I have drawn there is acceptable. You will get full credit on a test if you go too high, because I don't expect you to sit around plotting any more points than this. Actually, that is it. You know what? There is something that bugs me about my graph, though. Do you see what I'm talking about? I'm going to do a little bit of mending and see if that makes sense. If I want to go up really, really high, I actually need to stay in between -3 and -2. Do you see that I drew something that actually wasn't a function? I'm not allowed to move left. Yeah, anyway. Oh, we have 5 minutes left. So, that got us through the necessities. And other than that, there's a little bit more practice for you to do here. And I'm going to expect you to finish the classwork, but you've got the answers already. Is number 5 wrong on the homework? Classwork. Let me see. Number 5. I didn't write the remainder. Was that what you were seeing? Or was there more than that? I'm going to turn off the recording.